Hi, everyone, and welcome to this Wi-Fi Now feature interview. So my name is Klaus Hetting, and today my guest is Dirk Franklin. Dirk is General Manager, North America, and VP Business Development for a company called Deeyook. And Deeyook has a completely new approach to high accuracy location tracking with Wi-Fi. Dirk, first of all, great to see you. Welcome.
Yeah, great to see you, Klaus.
So this is super interesting, and as we know, location is a super hot topic these days for a number of reasons. There's a lot happening, but your approach is something totally different. So Dirk, let's just jump directly into the story here. I'm going to let you present a few slides on what this is all about, right?
Yeah, thank you very much. So Deeyook is a Hebrew word for precision, and we're all about precision location of everything, anywhere, anytime. So what we do asset location automation as a service. So we're a LaaS. Our secret sauce, and Klaus, this is what you were mentioning before. We do something very, very different. So our approach is patented interferometry in an AI-based physical model. We have 9 granted US patents, so we're a technology company through and through, 10 more pending. And what our approach on Wi-Fi based RTLS, what we've done is enable the world's 8.5 billion access points worldwide to be part of our terrestrial tracking system. So passively, so we're using the global Wi-Fi install base for our solution. So that's what's really unique. Our traction is with Fortune 500s, manufacturing, supply chain, logistics, back-end retail. We're a middleware software company based in Tel Aviv and offices in Silicon Valley. The overarching problem statement we get from our customer base is, where is my stuff? It does not get more basic than that.
That's true.
It's very true. So it's, and we lived it via COVID, but, warehouse distribution, now you have instant hyper-localization of your inventory. You could get to the full digital supply chain. So products going out on a truck, you get a digital advanced ship notice. On delivery, you could get a digital proof of delivery. And this prevents large companies from their compliance fines. Some large multinationals paid $20 million a year in fines for inaccurate deliveries. So this is a real big problem. Manufacturing the same. Yard management, getting the tractor trailers moving through the distribution centers quicker. It all means time, which means there's a lot of money here. And so what have we done different? So our breakthrough, we talked about interferometry. Really, what is that? That's physics, principles of physics. It looks at 2 coherent light rays and looks at their interference pattern, right? And we gather information from that information or phenomena, the interference. We extract that, we calculate that, and we can understand precisely where an item is. And then we also have this AI-based physical model. So our model dictates the interference patterns of Wi-Fi signals at any point without us being there before to take a reading. And then we use numerical techniques and back calculate. We reverse the model numerically. And then when we see an interference, we know exactly where that would be in space. So we create this model of angular space.
So this is something that you do with some AI mechanisms and so on. So you can actually do this for, let's say, a warehouse, for example. You can create a model of this space essentially, and then through this method, which you just outlined, you will know where these devices are, basically.
Absolutely, which means your people, forklifts, assets, inventory.
And this is not standards based. This is simply physics, passive physics, if you like. Passive in the sense that you're listening to some signals here, but you're not accessing anything from the network side, correct?
Exactly.
Yeah.
So it's a whole new spin. It's like there's this massive install base of Wi-Fi. What can you do with it to deliver value to the customer? And we've figured this out. And it's interesting because we're getting direction of departure from an access point, which the access point is beaconing out a non-directional signal. Right. So we're we're extracting information in a very clever way to do what we need to do.
Cool.
All right. So there's a lot of, and Klaus, you had noted, there's a lot of activity going in real-time location services, a lot of different technologies. On the outdoor side of the fence, there's GPS and cellular. It works pretty good. There's problems in dense environments. It doesn't work indoors. So it's not a ubiquitous technology. So, our core thing to really solve the problem, ubiquity, scalability, precision, right? And then on the indoor side, we have BLE, which requires the deployment. It's not ubiquitous. Scalability, with buying infrastructure. Precision's not so good. When we say precision, we're looking at sub-meter accuracy. And then we have the legacy Wi-Fi, the active technologies where you would need to associate with the network, RSSI and time of flight, and those have challenges. One thing that's different between interferometry and the RSSI power or time of flight measurements, those are based on the speed of light, a very big number. And when there's small changes in the power, right, of the RSSI value, that translate into a big inaccuracy once you do your calculations. We look at angles. So as the RSSI signal would go through a wall, two walls, the office staff, inventory. You don't know, the power drops 10, 20, 30 dB. And are you 150 feet away or are you 15 feet away, but gone through the walls? And with interferometry, we only care about the angles. So if you go through a wall, lose 10 dB, we don't care. We look at it, we see the signal and we see the angles. We know exactly where that item is. And so, again, to look at this, we are passive. We sniff the Wi-Fi that's around us. We do our interferometry. And so we could essentially leverage the world's install base of Wi-Fi and deliver 10 centimeter accuracy.
That's crazy accurate compared to what we usually hear about in Wi-Fi, certainly, right?
Right. I mean, some are 10 to 30 meters accuracy.
Yes.
And that's a zip code. If you have a warehouse worker with a scanner, right? He could only see 3 or 4 feet around him. If you get him into a sub-meter, the search and find issue becomes very, very small.
Absolutely.
We have some customers we're in pilot with that they run big manufacturing sites, and they have a team of 50 with the title search and find. And that's what it takes for them to run their factory optimally. With Deeyook, you'd walk right to the item. So it's a huge cost savings and time savings. And to look at how this system actually works. So here is kind of a block diagram of what we do. In the center where that package is a Deeyook enabled mobile device, could be some sort of tag device, and it's looking at the incoming transmissions from the local access points in the environment. So we use interferometry to measure that phase differential at the tag. We stream that to the cloud. We determine the angle. We do that 3 to 4 times. We determine exactly where you are in angular space. And that goes back to our AI-based physical model. So we have this angular space model that gets built out as we learn more and more as the tags discover APs. And then we translate that to a known spot on a physical map.
Cool. Do you need to prime the system, so to speak? I remember we talked about this when we first met. Or is that not necessary? Because you kind of think that your system needs to learn about the space first, or is that kind of built in simply by operating in the space?
Well, a little both. So when you start from ground zero, you anchor to a known physical spot. That could be from an HD map. It could be just knowing the facility. It could be with GPS. And in the future, as our model grows and grows and grows, we already know the location.
Right.
So it's a known existing location out of our database.
Right. And you do need to connect your the device, the tagging device, to some form of backhaul, as you very well describe on your slide there, right? But that could be a Wi-Fi network belonging to the operations, for example, of the facility, right?
Yep, correct. Or
Yeah.
if it's going to be a multi-facility type application, or you're doing pallet cycles through a whole distribution process, you'd go LTE.
Right.
And then you have that. And just to complete the message here, we talk via API to the work stream of choice. So whatever our customer's running, SAP, Manhattan, et cetera, Oracle, we talk right into there and put the location as they need it into their work stream.
Very cool.
So yeah, we're very excited about this, and the nice traction coming to market.
Absolutely fantastic. And in many ways, you could say it's a complementary way and completely new way of thinking location-based services and Wi-Fi, because a lot of what we're seeing, of course, in Wi-Fi these days is standards-based, and the new standards, I think they say, is sub-meter and so on. But this is doing things a completely different way, and down to even higher accuracies, right? So it's super exciting to see that these things in fact exist. My best guess is that there are very few folks out there that have any idea that such things in fact exist. So we're super happy to have you to shake them up a little bit, right?
Yeah, absolutely. And this goes back to the OFDM signal, and that started with 802.11n. So if you think about it, all the equipment on the planet is at least N or later, and Wi-Fi 7 is great. It also supports Deeyook's technology,
Yes.
And
exactly.
So the install base is there waiting for us.
Right. And it's independent of, exactly as you said, of what version of Wi-Fi is installed. So it's not, so that really doesn't matter. So there's a lot of super progressive things here. Dirk, can you say a little bit about the status of the product right now? I heard you say that you were doing some testing with some clients, right?
Absolutely. Yeah, we're at the MVP stage. We have multiple pilots underway, a bunch more this fall, and we expect first revenue early 2024.
And how's the market reacting to this? What do people say when you present this solution to them?
They're a little bit blown away. There's a whole dichotomy of indoor locationing. This is really a major pain point, is indoors.
Yes.
And one customer said, well, we know if it's inside or outside the building.
That's all.
And their warehouse is 1 million square feet.
Yes.
Other people know, hey, we know within 30, 40 meters, but again, the search and find time goes up. So, this is really a pain point, and people are super excited about it.
Right. So the first commercial installation, do you think later this year, or?
Yeah, we'll have it up and running in early January, February 2024 is our current plan.
Fascinating to hear about this. And as I remembered, you're also coming to our Wi-Fi World Congress event in Toronto, right?
Yeah, that's going to be great. I'm looking forward to it.
That's going to be fantastic. And I'm so looking forward to meeting you in person. I think we at Wi-Fi Now, we love this sort of innovation because it's really completely different than what we're used to, but it's still, as you said, making use of potentially billions of Wi-Fi access points out there, and they don't even know it because you're basically using them passively, right? So
absolutely.
Yeah. Dirk, it's great to have you. Thank you so much for coming on. We're going to share if we may, if you will allow it, your email in the post below, and people can contact you if they want to know more. And if they want to meet you, folks out there watching, come to Wi-Fi World Congress Toronto, and Dirk will be there, and I'm happy to introduce you to him, and I'm sure he has a lot more to tell you. So Dirk, great to have you, and thank you so much for coming on.
You're welcome, Klaus. Pleasure is all mine.
Great. All right, folks, that is it for this interview. Thanks a lot to Dirk Franklin from Deeyook and for coming on the program. So don't forget, we're only 5 weeks away from Wi-Fi World Congress in Toronto, Canada, featuring probably the best program and finest list of expert Wi-Fi speakers that we've ever had come on in any event. So don't miss it. It's taking place at the Omni King Edward Hotel in downtown Toronto, Canada, on September 18th to 20th. Go to our website, get your ticket now while tickets last, and keep following us for, of course, lots more cutting-edge information from the world of Wi-Fi. Remember, if you haven't already, remember to subscribe to this channel on this website to receive weekly news and updates in your inbox. That's it for today. Thanks and goodbye.